All right, now for law of cosines. These situations, side, 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 side angle, side. So law of cosines, A, B, and C are your sides, and then A is the angle opposite this one. So they give you 3 different formulas, but it's the same thing. This is that pair, the side opposite this angle, and then these are B and C are your other 2 sides. So for a situation like this where you're given 3 sides, it doesn't matter which one you do first, but whatever one you put on the outside, that angle is going to be the one that you're going to find first. And when you're given this situation, I recommend that you just plug it in and use the law of cosines 3 times, because what could potentially happen is if you find an angle and then you try and go back and use law of cosines, or excuse me, law of sines, then you might run into the ambiguous case. And it's not the ambiguous case because they gave you one triangle. And so if you have a situation where you need to use law of cosines, if you stick with law of cosines, you will not go wrong. So I have 6 squared equals 24 squared plus 20 squared minus 2 times 24 times 20 times the cosine of angle A. And we can draw a picture. Sorry, I should have drawn a picture. A, B, C, A is 6, B is 24, and C is 20. So I'm going to look for angle A first. Now, this is the easy part. I have people who will add these up and then subtract this number and this number. This is whatever, 2 times 24 times 20, is a coefficient on here. I can subtract these 2, and then I have to divide by this number, okay? That is one of the most common mistakes that people make with this. So I'm going to take 6 squared, and I'm going to subtract 24 squared and subtract 20 squared. So 6 squared minus 24 squared minus 20 squared. And I can do that all at once on my calculator. And I end up with a negative 940. There's kind of a little bit of a glare there. Now you can see it. Negative 940. Okay? And then I'm going to multiply those together. So negative 2 times 24 times 20. So I have a negative 940 on this side equals a negative 960 times the cosine of A. Then I divide by this number, okay? So I take a negative 940 divided by a negative 960. And I'm going to keep that number on my calculator, okay? I'm not going to use a decimal approximation. You certainly can write something down. This is like a negative 0.979 equals the cosine of A. To find A, then, I have to do the inverse cosine of this. So the inverse cosine of this 0.979 equals angle A. Oh, goodness. Inverse cosine of answer. There we go. So angle A is about 11.7. And I don't expect you to show me all these steps. I'm just showing you where people tend to make mistakes on these problems, okay? Now I'm going to go through and I'm going to find angle B. So I'm, again, going to use law of cosines. I'm not going to go to law of sines because of that ambiguous case yet. So I have B squared equals A squared plus C squared, my other 2 sides, minus 2 times 6 times 20. Those are my other 2 sides. These numbers will always be the same, and these numbers will always be the same. And then cosine of B. Now, I can do this in my calculator all at once. I can take 24 squared minus 6 squared minus 20 squared divided by, I'm going to put parentheses around that, and then take the inverse cosine of that. So I'm not going to take any extra time of yours writing this all down, and I'm just going to do it on my calculator. So 24 squared minus 6 squared minus 20 squared divided by a negative 2 times 6 times 20, and then the inverse cosine of my answer. And so angle B is approximately 125.7 degrees. And now that I've got my two angles, I can find angle C by subtracting from 180. There's no reason why you'd have to go through and do law of cosines a third time. If you do, you certainly should get that answer. But this is that situation. I ended up with an obtuse angle, and if you did law of sines at this point, you would not have gotten an obtuse angle. You would have gotten an acute angle, and then your angle C would have seemed rather large. But measure of angle C is going to be 180 minus 11.7 minus 125.7. And so this is approximately 42.6 degrees. So let's check. I'm going to go back up here to my lovely picture. Angle A was approximately 12. Angle B was approximately 126. And angle C was approximately 43. Now, if you notice, when I rounded all these actually don't add up to 180. This adds actually up to 181 because of rounding. So that's why there's an issue. If I add all of these up, I do get 180, but now that they're all rounded, I don't quite get. But the reason we're doing this is just, does it seem reasonable, okay? So largest angle, longest side, smallest angle, smallest side, and then in between. Seems reasonable, looks good to me. Okay, here's one more. This isn't a side, side, side. This is a side angle, side situation. Okay, so I'm going to draw my picture. Anytime that I get an angle, though, I'm going to force myself to draw this picture, because then they're not going to tell you if it's side, 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 or side, angle, side, or side, angle, or angle, angle, side. They're not going to tell you that. You have to figure that out. So if I'm given an angle, I am in the habit of putting my angle here. So then I have side A, which they didn't give me, and then I have B and C. Now, in this case, it doesn't matter where I put B and C because I'm going to have these two sides. This is going to be a 7 and this is going to be a 10. And so I have side, angle, side. I have that situation where I have side, angle, side. So I need to use law of cosines. So I can solve for this one first. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. Okay, and A was 34 degrees, so we can put that in there. But those two, whatever side and angle, those are the two that match. Okay? So I can stick this whole thing in my calculator and then take the square root of it. So again, law of cosines, basically once you write out the formula, it becomes a calculator problem, okay? Some of you might need to write a little bit more down, and that's okay. But in this case, I can take the square root of 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 34. And I can shove that in there all at once. And so A is approximately 5.7. Okay. Again, you can go to law of sines, but I'm still afraid of that ambiguous case, and I'm going to stick with law of cosines one more time. I'm not going to venture back and do law of sines. I'm going to stick with law of cosines. Now, it doesn't matter which one you use, okay? I've got my side A. I'm going to store that in my calculator as A. So then I can use that full number instead of a decimal approximation. So I'm just going to do B next. So 7 squared equals, now in my calculator I put side A, okay? And I guess I shouldn't use a capital letter there. It is a capital letter in my calculator, but A squared plus, and this is going to be my A in my calculator, plus c squared minus 2 times a, again, I'm going to use the value in my calculator, times c, times the cosine of, and then this is what we don't know. We don't know angle B. So I'm going to have to do 7 squared minus a squared minus 10 squared divided by this, and then take the inverse cosine. So 7 squared minus a squared minus 10 squared, and then divided by negative 2 times a times 10, and then the inverse cosine of that. So angle B is 43.0 degrees. And again, once you have your last angle, you can always subtract from 180. So the measure of angle C is going to equal 180 minus 34 minus 43. Oops. $103 degrees. So I'm going to go back here. This side was about 6. Angle C is 103. Angle B was 43. Smallest angle, smallest side, largest angle, largest side. In between.